Hey, good morning, year 3. So this is the lesson for Tuesday, the 21st of April, 2020. I just set up my learning in the way that we usually set up in school. So with a margin on the left-hand side, my date, short date, because it is maths, and my learning intention, and I underlined it as well. So today we're going to be exploring the distributive property or law of multiplication. Now, this may sound very, very complicated, but actually it is quite simple. And we're going to go a step at a time for you to understand what it's all about. So, just a little bit definition here. Again, don't worry about the wording. That sounds really, really complicated, but we're going to concentrate on this, and you'll see what this is in a bit. So, first things first, let me just read it for you and then break it down. So the distributive law allows us to distribute or to break up, just to break apart, large numbers into sum, differences, and products to help with calculations. Now, some of you may be saying, what is that all about, Mr. Martinez? Well, let me just show you an example of what it means. Or just one way, if we can represent the distributive property or law, or to break up large numbers to make our calculations easier. Okay, and we do it when we multiply. And we're going to be using this when we move on to the grid method tomorrow for multiplication. So this is very, very important, this particular law of multiplication, and it will come in handy throughout your schooling now. Okay, so let's start with a simple example, just for you to see what actually it means to distribute or to break up in multiplication. So, for example, we have 3 times 6. This is I know that you know, every single one of you would probably tell me right away the answer to 3 times 6, which I hope that you tell me that is 18. Okay, that's great. But we're going to use this particular example to help us understand the distributive law. Okay, so we have 3 times 6. Now, the distributive law says that we can break up, or we can, we can break up large numbers. In this case, 6 is my larger number, but I can select either or. It doesn't really matter. But let's go with our larger number, which in this case is 6. Now I'm going to break it up. So I have 3 here, and I'm going to break up my 6. Again, for some of you, you may think that this actually looks quite familiar, and it is partitioning. We're breaking up the number. So we're breaking up this number right here into 2 and 6. I could have done it into 3 and 3 as well, or 1 and 5. So there are many ways that I could have broken up this number, but I selected to go 2 and 4. So 2 plus 4 is 6. I think we all agree with that. Now for mild, I've asked you to represent it using a pictorial representation. So any examples that you choose. So this is what I mean by showing or representing it visually. Just because in maths we want to make sure that we represent things as visually as possible so that we can understand what is actually happening, because numbers, they can be quite abstract or very difficult to see. So over here we have my 3, so I have 1, 2, and 3. Now we also recall that multiplication was basically repeated addition, so we add that plus that plus that. Now, as I said, we have 1, 2, and 3, which is right here, but now I have distributed or broken up my 6 into 2 and 4. So I have 2 here, 2 here, and 2 here, and I have 1, 2, 3, and 4, and I have this. I needed to repeat it 1, 2, and 3, because that is what multiplication is all about. It's telling me that I need to repeat this addition of 2 plus 4 3 different times. And if I add all these together, okay, I will get my product, which is my answer to a multiplication of 18. Let me just double check that for you and prove it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So we do have that confirmed. So then I have broken up my my 6, or distributed into 2 plus 4, just to make my calculation easier. You may not see it quite yet because the numbers are quite simple, but when we get to larger numbers, you will see how this actually does help. Then I can also, so this is the same as, basically that's what the equal sign means. So what I have here has the same value as I have over here. So when I'm going to distribute it here, I'm going to have my 3 times 2, right? My 3 times 2 over here. And I'm going to have my 3 times my 4, which I have right here. And when I add these two, the sum, or my addition, my sum, that's basically, remember that the sum is the answer to an addition. So my sum, it will have to be 18. But let's prove it. Okay, so that, again, let me just go backwards a little bit. So we went 3 times 2, and 3 times 4, because we've broken up this number to help us with our calculation. All right. So again, I represent it using an array. This is an array, an arrangement. And I have 3, okay, lots of 2, 1, 2, and 3. So I have 2, 1 and 2, 3 times, right? So 3 lots, which again, my sum, or my product will be 1, 2, 3, 4, 5, and 6. And I'm going to add that to my other number, because if I didn't multiply this one, I would only have that. So I would just be multiplying 3 times 2, not 3 times 6, really, because I only have 3 times 2, but I also have to do the 3 times 4, which I have here. So that means that 3 times 4, or we have 1, 2, 3, 4, and I have 1, 2, 3 lots of 4, which is 12. So now I have my 6 here and my 12 here, and I'm going to add those two together, and I am going to get my sum of 18. Now that may seem quite complicated, but basically what we're doing is we're breaking up my number over here, this factor. Actually, if we want to call each component by its mathematical name. So we have one factor here, we have another factor here. We broke up or distributed the larger factor into 2 and 4. And then I just multiplied my 3 lots of 2 and my 3 lots of 4. And then I needed to combine them, or I needed to add them together to get my answer. Now, I know that you're going to be saying, well, I just could have done 3 times 6, and I know that that is 18. I don't have to distribute it in this way because it is quite confusing. And that, you may be right. However, what's going to happen is, as the numbers get bigger, this is going to help us out to do this type of calculations. So I have an example here of 5 times 32. I can partition this number into 5 times 30. I'm just going to write this down right here. So I'm going to partition. So that is equal to 5 times 30, and I'm going to put it in brackets here because I'm going to do this one first, and then I'm going to add again. So I've partitioned 32 into 30 and 2. So then I have to add 5 times 2. Now, ideally, I would like you to represent these using arrays in this manner. So that would be 5 lots of 30. That's quite a lot of drawing. But I want you to represent and to see what you're actually doing. So you actually have 30 items. So for example, you can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. And now will need to do that 5 times because I have 30. I have 5 lots of 30. And that could be one way of representing that. And then the same thing for my other one would be 5 lots of 2, and I will do this very abstractly just for you to see, but again using either an array or just dots like I've done here to show the representation, and that will be your mild, so you can select any type of multiplication to do that. So again, sorry, let me just continue with this. So that's 5 times 30. I know that 5 times 3 is 15, and if I multiply that by 10, that will give me 150, because 150 is 10 times larger than 15. And I am going to add 5 times 2 is 10. So then my answer of this sum, it is 160. So something that looked quite complicated as 5 times 32 and quite daunting at first, we use the distributive, that is mean we broke apart 32 into 30 and to 2 to make my calculation a lot easier. So that is the distributive property, and we're going to come back tomorrow as well when we use the grid method. If you have any questions, please leave a comment, or you can just email myself or Miss Edwards. I hope this has helped you to figure out what the distributive law of multiplication is all about. But again, if you have any questions, please send your emails to us. Now for mild, I would like you to select one multiplication and apply the distributive law to it. Make sure that the numbers are quite high for one of your factors. And the next one, so your spicy would be to explain basically what we've just done here in the video, what you think the distributive law of multiplication is, and your hot would be to actually create some yourselves and just to explore as well, so you get very, very proficient, or you get very good at doing this distributive law. All right, have a wonderful day, everyone. Take care. Bye.